This PowerPoint is the first of a series of 3. This week, we're going to start with appraising studies of intervention number 2, looking at descriptive statistics as well as inferential statistics. This specific slides presentation covers everything you need to know about descriptive statistics in order to be able to understand the scientific literature. I think the key phrase there is to be able to understand the literature. We as physical therapists are going to be consumers of the literature. We're not going to be producers of the literature. So as far as statistics are concerned, we don't really need to know how to do the statistics. We need to understand how to interpret and read the statistics. We need to be able to do this because we have to determine if it's a good study or not, and if the statistics are done incorrectly or the results aren't valid, then we really don't want to use that information when we're treating patients in the clinic. When a researcher does a study, they design and perform the experiments, collect the data, summarize the data, and interpret the data. Summarizing the data and interpreting the data overall can be classified as statistics. In general, there are 3 different categories of statistics that we're going to learn about in this class. First is descriptive statistics, and descriptive statistics, just as it sounds, is that we formulate a description of reported data. Descriptive statistics is often used to describe parameters of different subjects in an intervention study. The next kind of statistical category that we're going to talk about this class is inferential statistics. And inferential statistics are essentially trying to figure out if things are different. Are they the same, and are they different, or are they different? Next week, we're going to talk about clinically relevant statistics. Oftentimes, inferential statistics give you a yes/no answer, while clinically relevant statistics, such as confidence intervals and effect sizes, are going to tell you not really yes, no, but is there any effect or any difference when you apply this intervention to the patient population? The rest of this PowerPoint is going to be describing descriptive statistics. In general, descriptive statistics uses 2 different kinds of data. If you look at the figure on the right side of the slide, you can see data in orange and yellow, and it's broken down into 2 different boxes. The first box is known as categorical or qualitative. Categorical and qualitative data just get labels. Okay, it's just each label or each group is categorized as something. Categorical data can also be dichotomous. Dichotomous just means an example would be yes or no. It could also be something like nationality. So for nationality, you can have German or English or even American, but it's just a category. There's nothing more to it than that. The other type of data is going to be your numerical or quantitative data. Numerical or quantitative data deal with numbers, and these numerical values represent some sort of measurement. Anytime you can use those numbers in some sort of mathematical function, it's numerical data. I think one of the best ways to describe to you the difference between the qualitative and quantitative data is to look at an example. And this slide shows a medical records example. We have different categories across the top. You have individual people, you have gender, age, weight, smoking, and race. And under each category, I have for gender, male, female, M and F, age, the person's age, weight, person's weight, smoking, whether they smoke or not smoke, and race. Here in this description, I have white, Black, Asian, and Hispanic individuals. So if I had to look at the gender only has 2 choices. You're either, in this example, male or female. Okay, that's a dichotomous situation, and dichotomous situations are always qualitative or categorical. Next category, next column, I look at the person's age. Age here is a number. I can say that individual number 4 is a little less than half the age of individual number 1. That's a mathematical function, so this must be continuous data or numerical. Same thing applies with the person's weight. Those are numbers. Those numbers mean something. 110, I know, is less than 300. So numerical data, quantitative. Smoking, again, another dichotomous situation. It's either yes or no. Yes, that individual smokes, or no, that individual does not smoke. Dichotomous is always going to be categorical. You're categorizing whether or not the person smokes or not. Again, the last one, race. All the races listed are categories. Another thing you can do with categorical data is you can start to separate it out. If you look on the gender category, I have 1, 2, 3, 4, 5 males and 5 females. So I can list it. If I wanted to record it and condense that information, I can say 50% of this patient population was male and 50% of the patient population was female. Again, I can do the same thing with smoking and race. Oftentimes, categorical data is described as a proportion or a percentage. Hopefully that example made the types of data delineation a little bit more clear. Now we're back to the slide. I showed you this right before I talked about the example, and I just want to have you recall that there are two types of data. It's either categorical or numerical. And as it turns out, categorical types of data can be broken down further into two different categories. Those two categories are shown in this slide, where you can see, if you look at the picture on the right-hand side of the slide, categorical or qualitative data can be further broken down into either nominal or ordinal. Nominal data is just a label. It is a label with a word. It can either be two categories, which I mentioned previously as dichotomous. It's just one choice or the other. So an example would be yes or no. Or nominal data can also be more than two categories. An example of that would be some sort of religious affiliation or a nationality or race. Okay, all those are nominal. They're simply words. You're labeling something with a particular word and placing it into a category. The other type of categorical data is known as ordinal data. Ordinal data is just a rank order. And probably the most common thing that you'll see as an example for ordinal data would be something known as a Likert scale. The Likert scale is that scale when you're filling out surveys, you see number 1 equals strongly agree and number 5 equals strongly disagree, with 4, 3, and 2 in between, indicating the choice there. The choices are all categorical. They're words. It's either strongly agree or strongly disagree, but there's also a number associated with it. But that number can't really be used for any type of mathematical function, because we know that strongly disagree is not 5 times less than strongly agree. And moving on to the other main type of data, the quantitative data. You should be aware of the fact that this data is sometimes called continuous. It's continuous because numbers can be used for calculations. Examples I've given previously are indicated there on the slide, and you can use this numerical data to do mathematical functions. So let's move on and talk a little bit more about the quantitative or continuous data. When you can examine the distributions of this kind of data, and if you plotted out specific numbers, let's say you were looking at height from a large number of individuals from a specific population. If you plotted this large number of individual heights on a curve, you would see something that looks like the picture that you see on the left-hand side of the slide. If you consider the example for height, on the x-axis would be all the individual heights. So say going from the far left-hand side to 60 inches all the way up to the far right-hand side to maybe 75 inches. And on the y-axis, you're looking at the number of individuals that all share the same height, where it's a nice bell-shaped curve. And this bell shape has a special term. It's called normally distributed data. Normally distributed data has the mean, the median, and the mode all at the same point. Okay, the mean is the average. The median is the middle number of all the data, and the mode is the most frequent number in all the data. This is contrasted to the picture that you see on the right-hand side of the slide, where the data is no longer in a nice bell-shaped curve. It's actually skewed to the right, and since it's skewed to the right, it's called non-normally distributed data. And this is important to know because if your data is not normally distributed, then the mean, the median, and the mode are in different places. This makes a really big difference when you're reporting the continuous data. Now, one of the cool things about having normally distributed data or data that falls into that nice bell-shaped curve is that researchers can report the data as a mean. If you see data reported as a mean, then chances are good it's normally distributed, as well as plus or minus something known as a standard deviation. Okay, this slide shows the bell-shaped curve as well as the different standard deviations. And if everything is equal, plus or minus one standard deviation from the mean represents, indicated as red only, 68% of the total population falls within one standard deviation plus or minus from the mean of the entire data set. Moving on to red plus blue, you know that within two standard deviations, 95% of the entire data set falls in plus or minus two standard deviations away from the mean. And finally, 3 standard deviations plus or minus from the mean encompass 99% of the total population. So here's just a summary table of all the things that I tried to talk about in this PowerPoint. The basic take-home message here is that the type of data dictates the type of statistics that will be used as far as descriptive statistics are concerned. You start out with nominal type data, then the statistic you will see is some sort of proportion or a percentage of the total. The data is ordinal. You're going to get a proportion as well as the range. The range is the lowest number and the highest number. And why that would be important, if you consider a Likert scale, you could have a range that goes from 1 to 5, or strongly disagree to strongly agree, or you can have the range go from 2 until 4 or 2 until 5. You really don't know, so that's why people like to report the range of the data when it's ordinal data. Next, you have your continuous, normally distributed data, which is reported standardly as a mean with a standard deviation, and sometimes the range is included as well. And if you have non-normally distributed or that skewed data, it's still continuous data, but it's not normally distributed. Researchers are more apt to report a median or a mode to indicate that this is not normally distributed data. Again, they'll give the standard deviation and the range here, but you should realize that the normal proportions, so plus or minus one standard deviation, is not going to be 68% of the total data because the data is skewed. So be really careful when you're interpreting the data to check to see if the researchers are reporting the mean or the median or the mode.